So what we're going to be looking at is we're going to start with 2, 5, and we're going to look at 8 and 9, and these are the applications. Now, when we look at 8 and 9, okay, 9's the application, so let's look at 8 first. So we're going to do 8 and 9. Now, 8 is perpendicular. So let's write up what we've got and then see how we would proceed. So we've got the original equation, which is 8x minus 7y equals 127. And we want it to be perpendicular. And it has to go through this point. 8, 9. Okay, so it's got to be perpendicular to that line, and it's got to go through this point, 8, 9. Now, what are we going to do? What do we have? We have a line equation, right? And we have a point. So we go to the third page of our flow chart. And what are we doing here? We are trying to find the equation of a line given a point, right, and a line equation. So what do we need to do first? Okay, the first thing we do is we solve that equation for y. Follow the directions here. So we've got our equation. So we're going to take this equation. We're going to solve it for y. Right, yep, we've got to find that slope, the m. And so we've got 8x minus 7y equals 127. So we'll move that 8x over. And that gives me a minus 7y equals a minus 8x plus 127. And we'll divide everything by a negative 7. And that leaves me then in slope-intercept form with y equaling now. Negative and negative makes it a positive 8/7 x minus 127 over 7. Are you okay with that so far? Now, what is the slope that we're going to be using here? Okay, this is a slope that is our m. So that is 8/7. But that's not what we're going to be using, is it? Right? That's not what we need to use, because what are we going to have to use? We want the perpendicular slope. And that's going to be the negative reciprocal, so we're going to have to use m equals negative 7 what? 8. So that's what we have to use, because what do we want here? We want the perpendicular slope. So we flipped it over, and we changed our sign. Now what do we use? Okay, now if we follow it, right, we went down the perpendicular side, we use the negative reciprocal slope, and now we use our point slope formula, don't we? So now we're going to use point slope. And we're going to use point slope with m equaling that minus 8/7. And we're going to use that point 8, 9. Right. You flip it over, right? Flip the fraction over and change the sign. So this was a positive. Okay, so I flipped it over and I gave you the 7 over 8. And I changed the sign. This was positive, so I changed it and I made it what? Negative. So flip the fraction over, that's called reciprocal. And then I changed the sign and it was positive, so I make it negative. Okay, does that make sense now? Yep. Flip it over, that's reciprocal. When we say reciprocal, that means we flip it over. And this was positive, we change that sign and do the opposite. So positive, we change it and make it negative. So flip it over, reciprocal, change it on the sign. And then use your point slope, which is y minus y1 equals m times x minus x1. Okay, and yeah, can we finish it from here? Do we need to finish it? You can finish it, right? Yep, okay. So you can finish it from here. But does it make sense what perpendicular means now? Flip it over, okay, so switch it, change the sign. Question 9. We're going to read it, and we need to make sure we know how the ordered pairs go. So let's take a moment to read this. A biologist recorded 6 snakes on 16 acres in one area, and 15 snakes on 33 acres in another area. Find a linear equation that models the number of snakes in X acres. So what I want here is the last piece. It says X acres. So what do I know then? X is going to be the acres. So when I make my ordered pairs, X equals the acres. Y is going to be the snakes. So what does my ordered pairs look like? Okay, they look like acres, comma, snakes, right? That's what it needs to look like. Acres is the X part because it says right here, X acres. Okay, so X is going to be the acres. That means that Y has to then be what? Number of snakes. And so what does my ordered pair look like? Acres, right? Snakes. What do my ordered pairs look like when I write them out? Okay, let's make sure we put them in the right order. We've got 6 snakes on 16 acres of land. So acres goes first, so that's 16. And we got 6 snakes on that. And then we did another survey, and it says 15 snakes on 33 acres. So the 33 acres goes first, because that's the area. And then we found the 15 snakes. Can you finish it from there, do you think? Do we know what to do from there? Yep, you're going to have to find the slope, which is m equals y1 minus y2 over x1 minus x2, right? That's going to be finding the slope, and then use that then to get your line equation. Does that make sense on that one now? But you see how I got the ordered pair set up that way? Because I read it, and I saw what it wanted, and I made sure, because this is your x, this is your y, I made sure that I put them in the correct order. Then you use your slope formula, and then you'll use point slope from there. So I think you can finish it from there. Let's look now at 2, 6, and 7. And we're going to begin with question number 2. And for question number 2, we've got f of x equals 1/5 x squared minus 6. So what we're going to do is we're going to graph this one out. Okay, and then we're going to determine which one is the correct answer. So when we look at this, we have to figure out what the graph is going to look like. And what is the graph going to look like? It's an x squared, right? So what does the graph look like? Should look like that. Okay. Now, we're also going to have to worry about the stretching and how that works as well. So where do we begin? So we know it needs to look like this. So we automatically know that it looks like that, doesn't it? What about the minus 6? What does that do? That's on the end, so that forces it down. So where am I going to start at? Okay, I'm not moving it left or right, so I'm going to start at 0, comma what? Negative 6. Okay, so there it is, right there. That's where I'm going to start, at 0, negative 6. Now, what about that 1/5? Well, that 1/5 is 1/5 over what? 1. So we're going to go up about 1/5 and over 1. So that's going to be up very little and over 1. Okay, and then we curve it. So it looks like that. Now, how do we get the other side? Okay, we do the opposite. So up about 1/5, back about 1. And so that's about there, right? And so there's my picture. Now, let's look at our choices. Why can I eliminate B and C? Right, because that's moving to the right, and that one's moving to the left. What are we doing to my graph now? Yep. Okay, we're moving it down. So that means it's either A or what? A or D. Now, what's in front of my x squared? 1/5, right? So that means it's going to be A. We're shrinking this graph vertically by a factor of 1/5. So we moved it down 6, shrinking it by a factor of 1/5. So what would the answer for that one then be? That would be answer A. Is everyone okay with that one? Right? And I just drew the picture so we would see what's happening there. Question 7 is the next one that we're going to be looking at. Okay, so question 7. We're going to do the same procedure. We're going to graph it, right? Now, we need to make sure we label where it starts at. And when we look at this one, we first identify the picture that it goes with. So let's look at question 7. And we've got f of x equals now 3 times x plus 1, quantity squared, minus 2. So what should it look like? Again, the basic shape is going to be a U, isn't it? Now, where do we begin? I always start on the end. That goes down. And this positive 1, what happens with it? Back to the left, opposite of what you think it would do. So where am I going to start at now? Okay, I watch it as an ordered pair. As an ordered pair, I go to the left 1 unit, and I go down 2. So that's going to be at minus 1, minus 2. Is everyone okay with that? Make sure you, that's the most important part, is you identify where it starts at. Now, what about the 3 in front? That's 3 over 1, so we're going to go up 3 and over 1. Very important that we start at the right place. So we start back 1 unit, down 3 units. So that's right there at minus down 2 units. So minus 1, minus 2. So back 1, down 2. Is everyone okay with that so far? Now, what do we do from here? Up 3. So 1, 2, 3 over 1. So that's going to make my second dot right there. And you can label it if you want to, but you don't really need to. As long as you keep track of it, that's okay. So that is that piece. Now, how do I get the other part, the other half? It needs to look like that. So I go back to my minus 1, minus 2, and I'm going to go up 3 and back 1. So that's going to put the other point right about there. And I'm going to connect it together. And so there is my picture. Is everyone okay with how I did that? And you can label these points if you want, but you don't have to. Right? Like you could actually label that if you wanted to, that would be at 0, 1. But you don't need to if you're comfortable with how to draw. So what happened to the graph? We went down 2, back 1, so that started right there. And then what about the shape of it? Okay, instead of it normally being shaped about like this, right, it's tighter. Why? Because of the 3 in front. So up 3 over 1. Normally it would be up 1 over 1, and it would be like that. Right? A little bit wider. Ours is more narrow because of the 3. So that takes care of question number 7. And I think we may have forgotten 5. Yeah, I forgot to do 5. So we'll go back and get 5. Sorry about that. We'll go back and get question 5. Question 5 is f of x equals 1/4 x cubed. Okay, so for question 5, what does the graph look like? Okay, the first thing I always do is I remember what it looks like. And what does the graph look like? Yep, it's kind of like an S shape, right? Yep, looks like that, doesn't it? Okay, is everyone okay with that? First thing I did was it's cubed. Odd powers always look like this. Even powers, like this one, even powers look like that. So if that would have been a 4, it would still look like that. Even powers always look like this. Now, where are we going to start at? Right? Start at 0, 0, because there's nothing else along with it. So we're going to start right here at 0, 0. And what about that 1/4? Well, that is 1/4 over 1. And you just barely go up a little bit. So we're going to go up about 1/4, not very much, so up just a little bit over 1 unit. Draw the curve. Now, it needs to look like this. So how do we get the other side? We go down about 1/4, back about 1. And there's my picture, right? See how it got widened out, right? It's wider. Is everyone okay with that so far?
So when it says, what are you looking for?
Okay, when I look for this, what am I looking for when I grade this? I am looking for that point right there where you start at and the general shape. It needs to look like this, okay? Not really narrow. I want to see it widened out. So what I look for is when I grade these on your exam and in your homework, make sure you got the starting point labeled. I always look for that, and make sure it looks generally like this. That's the important takeaways. It needs to look similar to this, similar to a cube, and I always look for that starting point. If you're off a little bit, that's okay, but it needs to look like this and definitely not a U. So look in this shape. Okay. Question 8 is next. So question 8. Question 8 is an absolute value. And that's y equals 6, absolute value of x minus 3. So what is the picture going to look like? It's going to look like a V, isn't it? Not a U. I need to make sure it looks like a V. So this is an absolute value. So it makes a V. Not a U, a V. Is everyone all right with that so far? Now, where do we begin? Watch the ordered pair. That's going to be at 0, comma, negative 3. Because that negative 3, that's the down part. Yep, and then we've got a 6 over 1, don't we? So we're going to be going up 6 and over 1. So this is where we start at. And we start at 0, negative 3. So that's down 3 units. And then what do? Up 6. So 1, 2, 3, 4, 5, 6 over 1. Make a dot right there. Now, we don't connect it with the curve. We want it to make a V. So we do the sharp line there. It needs to look like this. So we do the same on the other side. Back one. Now, what am I looking for when I grade it? I want to make sure that it looks like a V, and I want to make sure that it starts down here 3 units down. And it needs to be narrower, right? It's been pulled in 6 times, so it's 6 times as narrow. It's been pulled way in 6 times. Okay, so that's what I look for, is something resembling that. Make sure it's a V, not a U. So make sure it looks like a V. And make sure it's been slid down 6 units. Question 9. Question 9 is a cube again. Okay, so we've got y equals 1/3 x minus 4 quantity cubed. So the 4 is inside, so that means it is moving it to the right because it's negative. So it's going to move it to the right or forward 4 units. So where do we start at? Yep, we're going to start at positive 4, right? 0. Oh, am I looking? Okay, make sure we're on question 9, right? So this negative 4, that's going to move it over to the right, and we move it to the right. We change our sign, so that's going to make it positive 4. And we're not moving it up or down, so that's positive 4, comma 0. Is everyone okay with that? Right? What's the graph going to look like? Yep, looks like that. That's your x cubed. So let's find out where we start. 2, 3, 4. So right there, we're going to start right here at 4, 0. And that 1/3, well, that is 1/3 over 1. So up 1/3 over 1. So we just go up a little bit, up about 1/3 over about 1. Make our curve. How do we get the other side? We go down about 1/3 over about 1. And there's your picture. Is everyone okay with how I slid that around? And once you start doing these, you'll find that they are very easy. It's just making sure that we set them up correctly. Question 10. Question 10 is the greatest integer. Okay, so question 10. And we've got f of x equals the greatest integer of x minus 1. So what is this going to look like? Okay, this is the greatest integer. So it looks like a case of stairs, doesn't it? Right? Looks like stairs. Okay, now let's see where we begin. So where do we begin now? Yep, so this negative 1 here, that's going to force it down, isn't it? So that is going to be now at 0, comma, negative 1. So that's where we begin. When we go to graph these, we always start with a closed circle. So we're going to begin with a closed circle. And we have a closed circle at 0, -1. Now, what do we need to do? We need to make it look like a case of stairs, and there's no number in front, so we know that it's a 1 in front. So that means we got 1 over 1, so up 1 and over 1. So we start here, and we go up 1 and over 1, make a dot. Up 1 over 1, make a dot. Up 1 over 1, make a dot. And then we connect them with an open circle below. Okay?
Do you have to do that?
At which part now?
With the open circle?
Yeah, it has to look like this with an open circle below. An open circle and closed circle are always on top of each other. If it's going up, if it's positive, the closed circle's on the top. If it's going down, the open circle is. So closed circle's on top, open circle's below it. And that makes your case of stairs. Now let's add a couple in the other direction, just so we get a good picture. And so we're going to go down 1, back 1, and down 1, back 1. And that's what your picture should look like, right? These are all open. All of those are open. These are all closed up here. So the open ones are down below, closed ones are on the top. Does that make sense on that one? And just look at it like a case of stairs. Just go up 1 each time. Up 1 over 1, up 1 over 1, up 1 over 1. Make your stairs. Make sure you got the closed circles below. The last one that we're going to look at is question 15. Now, I left 14 for you to do because 15 is the harder question. On your exam, there's going to be one like 14. Not 15. It'll be an easier one like 14. But let's talk about our function here. We've got 2x squared. We've got a 2. And we've got a 2x plus 1. And this is for x less than or equal to -1. If x is between -1 and 1. And this one is going to be for x greater than 1. So the first thing I need to figure out is what gets a closed filled-in circle and what gets an open circle. So the first thing I'm going to do is I'm going to figure out what gets what. So this one right here, closed circle, right? Closed dot. Why? Greater than or equal to, less than or equal to. These, what about this one, the second? Both sides are open, aren't they? And the last one, what does it get? Closed circle. And this is going to be row 1, row 2, and row 3. This is called a piecewise defined function because it's done in separate pieces or parts. Okay, so there's 3 different parts. Let's look at row 1. Row 1 here. Now, we need 2 points so we can connect them together. So row 1, I'm going to begin always by plugging in the -1, the number that they give you. So plug in that -1. If I plug in a -1, I have 2 times a -1 squared. Well, that is 2 times 1, which is then what? 2. So what would my ordered pair look like? -1, +2. Now we need another point. So we need a number, smaller than -1. So we can choose -2. and we plug it in. Yep, and this is going to be your y part. Yep, this is your y part over here. And what about when we square negative 2? When we square negative 2, it becomes a positive 4, and that gives you then your 8. So as an ordered pair, it's 2 comma what? 8. This one has to be done in separate parts. So let's go ahead and plug these points on our graph, or plot these points, and connect them together. It gets a closed circle. So we start at negative 1, positive 2. So that's right here. And it's going to get a closed circle. What's my next point? Negative 2, positive 8. So 2, 3, 4, 5, 6, 7, 8. So that's clear up here. And I'm going to connect them together. I'm going to use a little bit of a curve. Why a curve? Because it's x squared, so it has a little bit of a curve to it. Very important, though, this is a closed circle. Is everyone all right with that so far? Okay, now we move on to row 2. And I'm going to plug in my 2 endpoints. So I'm going to plug in minus 1 and positive 1. So let's plug in the minus 1. Okay, if I plug in a minus 1, and we're on row 2, if I plug in a minus 1, what do I get out? 2. So that's minus 1. You could, but on these you want to do the ends. It just makes it easier if you just do the ends. But you could pick 0 as well. Okay, it's going to be the same. But this way you get the nice line that you want. What about 1? Yep, if I plug in 1, I also get 2. And now I'm at 1, 2. So let's go ahead and plot these. There's my first one already there. And open circles can be on top of the closed one, just like that. So they'll be override each other. And then we're at 1, 2, so that's up here. And it gets an open circle. And the open circle and closed circle were on top of each other. So that just makes it a closed circle. Right, and you want to make sure you do that. That way you get this entire piece here. So that's why I have you check. 0 is in here, but go ahead and check your 2 ends. Check the 2 numbers on the end. That way you get the line that it needs to be. Okay, that way it makes the line look right. Yeah, this is going to make, you need to connect them. So I always pick the 2 ends. So you can pick 0. 0 is in here, but you got to remember you have to pick this point at the end here. So I always just pick the 2 ends and plug them in. Okay? 0 is in there, but in this case, you want to pick the 2 numbers on the end. Here. Okay, so row 3. What about row 3? We plug in our 1. And if I plug in 1, we get 2 times 1 plus 1. So that's 2 plus 1, which is then 3. So as an ordered pair, that's 1, 3. We need another number. Okay, so we're going to plug in 2. So that would be 2 times 2, right, plus 1, which is 4 plus 1, which is then 5. So that's 2, 5. Okay, so now let's go ahead and find them. 1, 3. So over 1, and this is only up 2, so we're going to go up 3. So that's going to be right here. I know it's hard to see, but it'll be right about there. It's hard to draw, I know, but that's going to be at 1, 3. So 1, 3 is a closed circle just right above it. And what's my next point? Over 2 and up 1, 2, 3, 4, 5. So that's right about there. And I'm going to connect them together with a line. And it looks similar to that. Okay, so what we've got is we've got this piece for the x squared part. Then we have a horizontal line here in the middle. And then we have the diagonal line here. So that is what your graph should look like. Now, when I go to grade it, I want to see it looking similar to this. I want to make sure that there's a horizontal, a flat spot here, kind of a curve over here, and then a line going up over there. Yes, this one's going to be a straight line here. Why? Because it's just an x, and that's a linear function, so it makes a straight line. Yes, I mean, it would be, I probably wouldn't take off points for that, but I would probably circle it, tell you it should be curved. Why should it be curved? Because this is x what? Squared. So it looks like that. And we only have half of the u. We only have a little bit of it. Okay, but if you made a straight line here, I wouldn't take off points, but I would circle it and tell you to make it a curve. Does that make sense now? Okay, and 14 is much easier. 14 just has 2 parts. So it's going to be an easier one for you to do. Now let's move on and work on 2.8. And then we'll work on our practice exam after that. (2.8) is a very, very easy section to do. So 2.8 is functions. More with functions. Now, when we talk about functions, all the normal operations apply with the functions. So f plus g of x is the same as f of x plus g of x. We can subtract f minus g of x is f of x minus g of x. Multiplication, f times g of x is the same. F of x times g of x. And division is the same, which is f of x over g of x. So all the operations that we do with numbers is also going to apply the same way with these functions. So you can add functions, you can subtract functions, you can multiply functions, and you can divide functions. We're going to start with an easier one. We're going to start with an addition. So what I'm going to do is I'm going to give you 2 functions. So you're going to be given f of x equals 5x plus 2 and g of x equals 9x minus 7. And I want you to find f plus g of x. So I want you to add these together. We replace this, so this is f of x, okay, plus g of x, right? We just write it out as 2 separate parts. Now, all we need to do is plug the parts back in. So what was our f of x? Yep, 5x plus 2. So that goes here. What is our g of x? Okay, 9x minus 7. And those can be combined and condensed down a bit. So now we can combine like terms. 5 and 9 makes it 14x, right? And 2 and a minus 7, minus 5. And that's your answer. That is f plus g of x. And that equals 14x minus 5. Okay, so all we did was we added them together. Now, when there's a variable inside the x, we got a variable out. If there's numbers, then we get a number out. So variable in, variable out. Variable, variable, number, number. So let's try one with numbers now. So I'm going to give you 2 new functions. About f of x is 4x squared minus 3. G of x is 2x plus 5. And I want you to find this. I want you to find f minus g of 3. Now, what are we going to have for our answer? Inside the parentheses is what? A 3, right? Number 3. So that means we're going to get a number out. Variable inside the parentheses, right? Variable here, variable out. Number in, number out. So we can now rewrite this. And we can rewrite this as f of 3 minus g of 3. Each one of those is going to be its own individual number. So we need to find f of 3. So I'm going to plug in that 3 into my f function, okay, f of 3. And f of 3 would be 4 times 3 squared minus 3. So 3 squared is 9. And that's 36 minus 3, which is then what? 33. Okay, and that piece gets replaced. So there's your 33. Now we repeat the process with your g of 3. And g of 3 is 2 times 3 plus 5. So that's 6 plus 5, which is then 11, isn't it? Okay, and we replace it. So that's going to come down now as an 11. And what's in between them? And now we've got 33 minus 11. That makes it a 22. And that is f minus g of, in this case, 3. So are we okay with that so far? Right? Plug it in. Now, number went in, number came out. Let's do multiplication. So let's try a multiplication one. And then we'll look at composition. So here's your two new functions. And let's go ahead and find f times g of x, which is f of x times g of x. Okay, so what are we going to be doing here? We're going to be multiplying. Now we may have to FOIL. What are we going to get out? Number or a variable? Variable, because variable's in, variable comes out. So we replace. So what do we replace f of x with? Yep, 4x minus 2. And what about g of x? Okay, yep, 5x plus 7. I can finish this out by FOILing. So we're going to go ahead and FOIL this out. And first times first, 4 times 5, that's a 20x squared. Outside and outside, so 4 times 7, that's a 28x. Minus 2 times 5, that's a minus 10x. And minus 2 times 7, that's a minus 14. Put it together, and that's 20x squared plus 18x minus 14, and that is f times g of x. Yep, and that's your answer. Variable in, variable out, right? That's the way you remember. You mean if there would have been a number in here? Then we would plug it in. We'll do another example. do one with a number. I'll do the same thing. How about just with a number? How about f of x is 5x minus 1, and g of x is 3x plus 7. And I want you to find g times f of negative 1. And we just write it. So that's g of negative 1 times f of negative 1. Okay, now, what's going to come out on this one? Number in, so my answer is going to be a what? Number. Okay, so let's plug it in. We do each one alone. So do each one by itself. And g is first, so let's do that. G of negative 1. That would be 3 times the negative 1 plus 7. So that's minus 3 plus 7, and so that's a 4. So we replace that with the 4. Are you okay with that so far? Same thing with the other one. What about f of negative 1? Well, f of negative 1 would be 5 times minus 1, minus 1. So that's minus 1, which makes it then a minus 6. So I replace it. And what are we doing with this? Multiplying them. So 4 times a negative 6, that makes it a minus 24. And that is g times f, in this case, of minus 1. Okay. Is everyone okay with how I did that? So number in, number out, variable in, variable out. For division, I may have you find the domain. And in this case, I want you to find the domain of f over g of x. Okay, now, when I talk about the domain, what does that mean? Domain means the numbers that give you division by 0. We have to take them out. Okay, so we need to find out where we have division by 0. So that means no division by 0. We have a possible division by 0 there, don't we? Right? So that's going to be one of them. There's going to be 2 of these. So no division by 0. So that means we take the x minus 2 equals 0, and we solve it, and we get our first number, which is 2. Because 2 would give you 0 here, and we can't plug it in. Now let's go back to our division here, and that is f of x over g of x, and that is 4 over x minus 2. And what's my g of x? Okay, 2x plus 3. Now, where else can we have a division by 0? Down there, right? Because that's another division part. So let's find it. 2x plus 3 equals 0. 2x equals a negative 3. So x equals a negative 3 halves. How do we write our answer? Well, this is where we have to remember how to write these correctly. This is how we would write the answer. Negative infinity to negative 3 halves union. Negative 3 halves to 2 union 2 to infinity. Now let's talk about what that means. What does this mean? This means every number will work except for what? What 2 numbers? Minus 3 halves and what? Positive 2. So I write it out like this because every number works up to a minus 3 halves. Every number works, but after a minus 3/2 to 2. Right? 2 doesn't work, and then anything bigger than 2 also works. So this is the way we write it up into the 3 parts. Where did they come from? Division by 0. Let's move on now and talk about the last part, which is composition. So we're still in 2.8. We're going to talk about function composition. When we talk about composition, it has a new symbol. And composition is the one operation that's unique to functions. And it has an open circle. And this is f composed with g of x. And this open circle here, well, that's red composed. Bless you. So that open circle, that's composed, not multiplication. It's composition. And when we do composition, we're splicing parts together. So one function gets sewed inside or put inside of another one. So that's our definition, and now we're going to apply it. So we'll do a couple of these, and then we'll spend about the last 20 minutes of class time working on our practice exam. So let's do a couple of these. So this is composed. Order is important too. You have to make sure they go in the correct order. And let's see, you're given two functions. Let's say you're given f of x equals 4x minus 2. And g of x is 3x plus 9. And let's try and find f composed with g of x. Okay, so this is what I want you to do. Huh? Oh, sure. Yep, no problem. Yep, see if that will work for you. Okay, so when I write this up, I have to make sure I put it in the correct order. Which one is first? F. So that means that F goes out in front. What's on the inside? G of x. We'll do this one with variables. We'll do the next one with numbers. Now, what is g of x defined to be? 3x plus 9, right? That's what g of x is. So I replace it. So it's just a replacement game. Right? G of x here is 3x plus 9. So I put it here. Now, what is my f function? Okay, 4x minus 2. I'm going to now rewrite it, and I'm going to put parentheses where the x is. And what's going to go inside of my parentheses here, do you think? Yep, 3x plus 9. And now can we finish it? Yep, we can distribute through. That 4. And 4 times 3, that makes it a 12x. 4 times 9 is a 36. And a minus 2. So that makes it, when I simplify it, 12x plus 34, isn't it? And that equals f composed with g of x. Variable in, variable out, right? Variable on the left side, variable on the right side. Let's now do one with numbers. So I'm going to give you two new functions. So let's say you're given f of x to be, how about 5x minus 1, and g of x to be x squared minus 3. And I want you to find g composed now with f of 2. So we've got to be careful on this one Because what are we going to get out? We should end up with a number out, right? Why should we end up with a number out? Because there's a number inside of the parentheses. So number in means we get a number out. Now, which one goes first in this case? Which one is listed first? G. So G goes in front. F of 2 is on the inside. What do we need to do? This one's actually a little bit more difficult, I think, than the last one. We need to first do the inside. What's on my inside? F of 2. So we plug our F of 2. We need to find it. And that would be 5 times 2, right? Minus 1. So 10 minus 1, and that is a 9. So the first thing we do is the inside. And notice this has a number on it, right? So we better get a number answer. So I evaluate it out, and I plug it back in. So now when I rewrite, now I have G of 9. And what's G of 9? Okay, G of 9 would be 9 squared minus 3, which is 81 minus 3, which is then a 78, isn't it? And what is that? That is G composed with F of 2. So number in on the left, number out on the right. Just remember, numbers inside, number better come out. If the X is on the left, X comes out on the right. Let's look at one more of these, and then we'll work on our practice exam for about the next 15 minutes. So let's do one more of these. Sure we can. Sure. Sure. Yep. Am I going too fast here? Yep. Give me a second. Sorry about that. So, do we see what we did? So, we've got our function. G was listed first. So we put G in front. F goes on the inside. What do? We do the inside first. So, F of 2. We take it, we plug it in. Gives you the 9, and then we plugged it in over here, right? And now G of 9, what would G of 9 be? 9 squared minus 3, so 81 minus 3, that gives you a 78. Now let's try another one. This one's going to have variables, and after this question, we will work on our practice exam. So let's try another one. And let's say F of x is 3x squared plus 2, and g of x is the square root of 3x. Well, let's make it 4x. That way it's not so confusing. Make that a 4x there, minus 5. So that's what we've got. Now I want you to find f composed with g of x. Okay, so which one's first? F is first, so F goes out in front. So G of x is on the inside. Now, what do we know about G of x? Okay, it's got a variable inside with the x, and what is G of x defined to be? Yep, square root of 4x minus 5, right? Is everyone okay with how I plugged that in? Right, I just replaced it. Now, what function are we working on next? What's left over? F. Okay, and what was our f function? It was 3x squared, right, plus 2. So let's rewrite this with parentheses. And what's going to go inside of the parentheses? Yep, square root of 4x minus the 5, right? Okay. Now, what do we know about a square and a square root? What happens when I square a square root? Okay, so this square and that square root are going to cancel. So now we're left with 3 times 4x minus 5, right? Plus 2, because that's square and square root, well, they cancel each other out. Now we can finish it. So distribute the 3 through. And that is then a 12x minus 15 plus 2. So that makes it a 12x minus 13. And what is that? F composed with g of x. And that is your final answer on that. I'm now going to go ahead and pass out the new practice exam. And we'll work on that for about 15 minutes. And our exam will be on Thursday.